Okay, so let's look at the detailed. In the next module, which is we'll look at the detailed example. As I said in the previous video, we were looking at some examples, like small examples of LCA comparisons. Now let's look at a detailed example of LCA comparison, and my goal in this particular video is to make sure by the end of this example, which may will go slow, we'll go step by step. My goal is to make sure that you have a very good understanding of how this LCA is done. So after this detailed example, if somebody gives you an exercise to do a LCA, you should be able to at least list down all the steps that is needed, how to go about it, how to do the exercise, and then of course you will need a software to do the detailed calculation. So let's look at this detailed example of LCA comparison. So we'll look at another example. What is the example? Compact fluorescent bulb versus incandescent bulb. Although this examples I prepared a few years back, so if now I think rather than using this incandescent bulb, I should go for a maybe then I need to make newer example where replace this incandescent bulb with LED bulb, because now LED bulb is more popular, but doesn't change our the discussion that we want to have. So say if you have an if you still, and many parts of the country we still use incandescent bulb, and some for outdoors we still use incandescent bulb anyway, and this is available in the market. So but say if you want to find out in terms of the compact fluorescent and incandescent, which one is worse, are they equal, worse or better, or which one is better, is the CFL better than incandescent? We kind of know the answer already, isn't it? Because because we know that CFL is better. That's why we have been using CFL extensively now. We don't, but in terms of the comparison, how we do the comparison and how the LCA exercise is done, let's look at that step by step. Now again, what was the LCA study consist of? This consists of 4 steps. We have to first define the goal and scope. That was very like we have to get this goal and scope of this study. Now here, what is the goal and scope? The goal and scope of this is to compare these 2 different types of bulb, CFL versus incandescent. Then we need to look at the life cycle inventory stages. Before that, we also have to do this functional unit and function and the functional unit, and we'll talk about that. Then there is a life cycle inventory stages, all environmental input and output. We'll look at that. Then how to go from there to the impact assessment, understanding the environmental relevance of all the input output, and then finally we will have to interpret the study, and we'll see that as well. So in terms of these 4 steps, so we'll go one by one of these. So if you look at this life cycle of a product, which is kind of again from time to time I'm kind of giving you a recap of what has been done earlier. All process associated with the product, wherever and whenever they might occur. So we have to get the life cycle where we get all the processes associated with a product, wherever and whenever they might occur. So if you look at this box over here, we can start with the resource acquisition. Remember that particular slide where I told you that you need to really understand this cradle to grave? The same information has been put in a different pictorial form over here. So you have your resource acquisition, where extraction and transformation. So when you do this extraction and transformation, we have put this Mother Earth in the middle. So this even in the extraction and transformation, there is an impact. So there is an impact during the extraction and transformation. Your mining engineers will tell you during the mining activities there are a lot of environmental impact. A lot of water is used, energy is used. You're creating a lot of noise pollution. You're creating a lot of dust and all that. So all these goes into in terms of the environmental impact. Then you manufacture, which is you make things out of that assembly and packaging. So while during the manufacturing you have the impact as well. From manufacturing you go to the distribution system, where you have the storage, handling and transport. During the distribution you have an environmental impact associated with that. During the use phase, where you have to do some maintenance, repair, reuse, and you will be using a lot of energy associated with that. So there also is an environmental impact. And then there could be some reuse within the system. Then ultimately it may go to end of life, where it could be collected, recovered, recycled, landfilling, and then there is an environmental impact associated with that. And part of it could be could be disposed, and part of it can come back. So that's your circular economy, the cradle to cradle. So from this arrow that you see, the green arrow, all the way up to here is your cradle to grave, where things gets out of the system. But if you include this dotted green arrow, it becomes cradle to cradle. So where you are kind of remanufacturing and like a recovery of the material and putting it back into the supply chain. So for all these steps, we have this environmental impact. That's why we have put this Mother Earth in the middle and showing you all the impacts coming in. So what we do in this LCA exercise is we kind of calculate and tabulate and add up all these different impacts that is coming into the Mother Earth, and in what categories of impact. Is it a global climate? Is it a global warming? Is it a climate, like a climate change or global warming? Is it acidification, or is it a land use impact? Whatever is a different kind of impact, we can put that all together. So let's look at the life cycle of a light bulb. That's so if we have this light bulb, incandescent or compact fluorescent, just so now if this light bulb, I want to manufacture this light bulb. So for manufacture, we need a lot of materials: glass, tungsten, copper, steel, aluminum, argon, electronic components, plastics, mercury, phosphorus. Think about just for as simple as a light bulb, these many items are needed to make a light bulb. And but these things has to come from somewhere, so we have to do this resource acquisition. We have to do this resource acquisition where it has to be extracted and transformed. So from the mining, it is extracted and then transformed by our metallurgy friends. Then it goes to the manufacturing plant, where we would get all of this together and then we assemble and make this light bulb. So once this light bulb is made, it has to be packaged, it has to be transported, and it goes to the distribution system. From the distribution system, you go and buy the product. You go to the use phase, where you use the electricity and you use it for lighting. You produce light. And at the end of life, when the bulb gets fused or something happens, it got broken because of some reason, it cannot be used anymore. So it's end of life, disposal, landfill, incineration, where it may end up. So this is the whole, and so this is the whole how the life cycle of a light bulb is from cradle to grave. So this dotted line, the dotted rectangle that you see from the outer boundary, this is our scope. That's the scope area, and we also call it system boundary. So this is the system boundary for this particular LCA exercise. So our LCA exercise is comprising of all the unit processes happening within this system. So this is what we will be trying to account for. So how we'll do that? First of all, we need to find out what is the function and the functional unit. Now, what is the bulb's function? Bulb function is to provide light, isn't it? That's its major function, is to provide light. And then we will do this environmental like LCA as an accounting exercise, where we'll look at the environmental impact, environmental intervention. Environmental impact is disturbance of natural cycles by environmental intervention, changes in the state of a natural environment due to human activities. So we'll look at all that, and that's for that functional unit. And so that's why we have to first come up with this functional unit number. So this life cycle inventory, resource acquisition, manufacturing, distribution, use, end of life. We have certain inputs coming into the system, some natural resource extraction, iron ore, crude oil, water, wood, solar energy, land use, all these inputs coming into the system in terms of the resource acquisition. And then you have your output, which is emissions in air emissions like carbon dioxide, SOx and NOx, particulate matter, VOCs, phosphate and nitrate in the water, pesticides, metals in the soil, and then you may have other environmental impact in terms of the radiation, heat and noise. So we have to, so as part of the LCI, which is life cycle inventory, we have to come up with a total of inputs as well as the total of output, and then we try to compare in terms of its environmental footprint. So for all of these, we have to do it for a functional unit. So the functional unit is the given amount of a function to which all inputs and outputs are related to. So that's like a base. Earlier, if you remember from the previous example we were talking about, we said 1 meter of writing. So we based it 1 meter of, that was the functional unit of using mechanical pencil versus the normal pencil, the wooden pencil. Similarly, here we have to come up with a functional unit where we are trying to compare this two types of bulb, where which bulb is better. So we need to do this calculation in terms of which bulb will perform better. So we have this life cycle inventory for that. So we have to have a functional unit, and based on the functional unit we have our reference flow. So functional unit is used for the product comparison based on the functional unit. Remember, we talked about the functional unit of serving of 30 meals, functional unit of 1 meter of writing. So in many cases one cannot simply compare product A and B because they have different performance. For example, again, comparing milk carton and a returnable milk bottle. Returnable milk bottle can be used many times. I don't know, these days it's very difficult to find a returnable milk bottle. We don't see them unless like most of the cities I've not seen it in India or even in abroad. But in olden days there used to be returnable milk bottle. If you have watched older Amitabh movies, Amitabh Bachchan's movie, you see that in some of the movies there is if the bottle comes in, they drop it in front of the door, they put it in a small, like there is one case like a holder, bottle holder, they put it on front of the door, and then they will put the call bell and they go away, and then the house owner will take it inside. So that's the bottle I'm talking about. The bottle can be reused. Similarly, we used to use we still use many of the bottles for say cold drinks, Coca-Cola, Pepsi, Thumbs Up, and all those. There is still use the glass bottles. So the bottles are still being used, but for the milk supply we don't use the bottle anymore. But we do use milk cartons and some milk pouches and all that. But say now if you have to compare, like comparing milk carton and a returnable milk bottle, which can be used many times, comparing them one to one, like one milk bottle versus one returnable one milk carton versus one returnable milk bottle, is not a fair comparison because the returnable milk bottle can be used multiple times. So here the comparing could be that you can compare the two ways of packaging and delivering 1000 liters of milk. So for both of them, for both the scenarios, if you want to package and deliver 1000 liters of milk, what will be the environmental footprint? Here we are giving them both equal footing. So that's the importance. Try to understand that. That's again that's why I'm trying to emphasize on this functional unit part, because the functional unit should give both the products or both the process, whatever you are comparing. If you're comparing two different process, two different products, the functional unit should give them the same fair chance. It should not be biased towards one process versus the other. So that's, you need to be very, very careful in doing that. Many times in when you look at some of these product LCA reports, which is done by the companies, they tend to do that. They will tend to try to show their product in a better light than the others, and then you need to look at their system boundary, how they in a very careful way to make sure they are not doing undue advantage to their product as opposed to the other product. So coming back to this life cycle of the light bulb, we have to have the bulb's function is the lightning, so to provide the light. So we know that the bulb function is to provide the light. That's their primary function. Now we have to define the functional unit. So for any LCA exercise you do, you can come up with a table like this. You can make a like a table like this and try to fill in the information, which we will do it with you. I will do it with you right now. So this will help you understand how we arrive at the functional unit. As I said in the beginning of this particular video, with this particular module, that we will go in great detail about this example. My goal is by the end of this example, you should be able to do a LCA exercise. At least you will have conceptually, you should be able to do it. Of course, you will need some computational help in terms of software. So coming back here, say if you want to do this functional unit, we have to find the functional unit. Now how we'll do that? We have two products that we are trying to compare, and that we have listed on this top over here, incandescent light bulb and a compact fluorescent bulb. So these are the two products we are trying to compare, and same thing at the bottom we have listed here. So now what is their primary function? If you look at here, I have listed here something known as secondary function, which we haven't talked about until now in this course. Now something is a primary function and there is a secondary function. So for this light, for this bulb, the primary function of course is to provide the light, whether you are looking at incandescent light bulb or you are looking at the compact fluorescent light bulb. So the primary function is to provide the lighting. But what about the secondary function? So if you go to any of these like a even like a sari shop or a chudi shop or any of these like a marketplace in the evening, you say that you see over there that hardly any place you will find people is still using incandescent light bulb. Most of the places they use compact fluorescent CFL, and of course they may be switching to LED now. But the reason for switching from incandescent light bulb to CFL, of course it's an energy saver, it helps in better energy efficiency, but it also gives a very good ambience as compared to incandescent light bulb. The incandescent light bulb has that yellowish light. So with the yellowish light, it's kind of gives a dull atmosphere, and with the CFLs or the LEDs, it gives a very bright light. So when you are in a marketplace, you want to show your product in a bright light so that the customers gets attracted. So that's also, it's a creating an ambience. But how to define that creating an ambience in terms of like a quantitatively? That's more like a qualitative. So it's very difficult to quantify that. So but that's the secondary function would be is a creating an ambience. And on the other side, if you are in like in the winter months especially, and some places where the heating is required, where they are possibly the chicken farm and other places, they tend to use incandescent light bulb more. The reason for that is incandescent light bulb gives more heat, so as opposed to CFL. So there is a like that's the secondary function, but how to quantify those secondary function? You can do that. You have to make certain assumptions to go about doing it, but we will not spend too much time on that part. That becomes like a more advanced LCA exercise. We will look at it later, but for now we will think about that primary function is lighting, but sometimes the secondary functions are also very important. Another example I will give you is that like a traditional book, that those hard bound books that you see, as opposed to like an e-reader where you can read things on your palm, like an iPad or Amazon Kindle and all those different e-readers available now. Say you look at any of the interview of the big like when on the TV, whenever even when our Prime Minister or the President is giving an address to the nation, many times you see them on the back of them will be a nice cupboard, book cupboard with a very nice books all lined up very nicely, different volumes, all hard bound, looks really cool. So it creates an ambience. Say if as a professor, if in my office over here at IIT Kharagpur, if I have a set of books very nicely lined up in my office, when you walk into my office, you get an impression that maybe this guy is reading a lot. Maybe, so that's, if he's reading a lot, that means he must know something. At least he will know something which I can learn from him. So that's create an ambience. It could be that I never touch those books. I mostly do my reading online, which happening these days, especially with the younger generation, not too much in our generation yet, or even generation older to us, but the younger generation, they tend to read online. But I'm not just saying, I'm not promoting online reading. I still feel that reading by book is the best way of reading, although you may call it outdated. You can call me an outdated old prof on this one, but reading by like a regular book, that gives you, even the research has been done where people have seen that the students who make notes in the older way in the classroom, and not the typing on the keyboard or the laptop or iPad or even these days on a smartphone, are taking pictures of the slides or from professor's slides or professor's handwritten material from the blackboard. What has been found, and there was a paper actually just came out last year where they found that the students who take notes by handwriting, they actually do much better in their classes, because when you write something by your hand, it gets registered in your brain much quicker. So now coming back here, so but those are things are also there in terms of the secondary function. But coming back here, if you have this primary function is the lighting, secondary function is heating and creating an ambience. As I said, for this particular example right now, we'll not worry too much about the secondary function. We'll take all like 100% over here in lighting, like 100% allocation to the primary function, although I use the word allocation, and which we'll talk about that later. And allocation where you can actually split the impact between primary and secondary, say by 60-40, 70-30, whatever. But Again, we'll talk about that later because that will complicate this stuff. Let's try to do stuff here in a simple way first. So primary function is lightning. Now think is that how much light, isn't it? That's the service provided. That will be our functional unit. So how much light we should take? I'm suggesting that let's take providing 700 lumens. So there is nothing hard and fast rule over here. You can choose whatever you want to choose, but it will be same for both incandescent as well as for the CFL. So that's the key here. It has to be the same so that you can compare. Why I choose 700 lumens for 10,000 hours? The reason for that is, for that I get a very good number. It's like I get 10 bulbs and 1 bulb. So I get 10 bulbs for incandescent light bulb and 1 bulbs of CFL, and this 10 bulbs 60 watt with 10 bulbs we have 600 kilowatt hour of electricity, and for 1 bulb I have 14 kilowatt hour of electricity. That's what it is going to, providing 700 lumens for 10,000 hours, and we can also do a lifetime watt lumen ratio calculation as part of this. So for any LCA exercise, you can start, especially when you are doing a comparative LCA, when you are comparing the two. Even if you are just doing one, you can just put one stuff here, but if you are doing a comparative LCA, which most of the times we kind of do this LCA comparing two different processes, two different products. So here you have, I would encourage you to make a table like this. Make a table like this and try to write it down. What is the primary function? What is the secondary function? What is the functional unit you can choose? What makes sense? And then once you know the functional unit, to achieve this particular, to provide this 700 lumens for 10,000 hours, we need 10 bulbs and 1 bulbs, and that is called reference flow. So this terminology is also very, very important, because when you start using a software later on, when you become when you get more pro kind of thing on LCA, you'll be using this certain software to use it, and then they will be use this terminology. So reference flow is the amount, like in terms of what is needed to provide the function as per the functional unit that we have chosen. So the function here was lightning. Functional unit we chose was provided 700 lumens for 10,000 hours, and to provide that for reference flow is 10 bulbs of incandescent and 1 bulb of CFL. So that's kind of I hope that this makes you clear. We spent quite a bit of time on this to make you clear on that one. So now let's look at this inventory of the light bulb. How we'll collect this data. So in terms of the light bulb, so our product system is the lightning need. We have the bulb. It needs to be packaged, and then we have this electricity. So the electricity that we supply. So we have this bulb and this the packaging material and the electricity. So for the functional unit is our providing 700 lumens for 10,000 hours. So that's what we have chosen. So reference flow, remember with the reference flow that we providing 700 lumens for 10,000 hours, we need 10 bulb and 1 bulb. For this incandescent bulb, we need 200, and to make 10 bulbs, we need 228 gram of glass, 232 grams of cardboard, and 600 kilowatt hour of electricity. Now we need to get the unit process, and how we get this unit process, it could be measured, it could be calculated, or the estimated data is specific primary or generic secondary data. So that's the unit process that we kind of use for that, and for each of these unit process we need the input and the output. So let's look at some. What we can get from the databases that I have mentioned, which comes with most of these softwares, we can get this data that for 1 kg of glass, what is the input goes into the system and what is the input output coming out. Here we have listed only three major. That doesn't mean there is only 3 input and 3 output. These are the major ones. The list could be endless. There could be a long list going out there. So in terms of 1 kg of glass, I have input as 94 grams of crude oil, 1 gram of iron ore, 1300 liters of water. So think about, to make 1 kg of glass, we need 1300 liters of water. That's why if you remember from the first week videos, I said that without water we cannot have any industry. We need good potable water to really survive, to make any industry, to have any GDP going on, we need good water. In terms of emissions, 0.52 kg of CO2, 0.26 gram of particulate matter, 2.5, 1.6 milligram of benzene. So this is what is, and again these lists are not the complete list. These are just the 3 top ones for the input parameter as well as for the output parameter. Similarly, you can get for the cardboard as well as for the electricity. For the cardboard, to make 1 kg of cardboard, you need 77 gram of crude oil, 16 gram of iron ore, 3200 liters of water. 1 kg of cardboard, 3200 liters of water. That's a lot of water. And then for 1 kilowatt hour of electricity, again, if you use the crude oil, iron ore, and then you use 19,000 liters of water to make 1 kilowatt hour of electricity. And these are the assumptions, emissions coming out, and we have taken carbon dioxide, particulate matter, and benzene are the 3 examples we have taken, but this is not the only ones. There are the other ones as well. So this is for the unit process. Unit means for 1 unit, isn't it? That's the unitary method you may have done in your maths class as well, long back in maybe in your primary school, or so maybe the secondary school, the unitary method where we put everything with the unit of 1 unit. So 1 kg. So here 1 kg glass, 1 kg cardboard, 1 kg of 1 kilowatt hour. But what we need is 228 gram of glass, we need 232 gram of cardboard, we need 600 kilowatt hour of electricity. So what we can do is, this is our functional unit. So per functional unit, we can take this data from here and then we can find out. So for 1 kg glass, this much, how much will be for 228? So same thing has been done over here. So for 1 kg of glass, 94 gram of crude oil. So for 228, 21 gram, 0.23, 300 liters. Similarly, the emissions we can do that. So this is assuming that things are linear. Similarly, you can do it for cardboard, you can do it for the electricity. Here the functional unit is 600 kilowatt hour, so we multiply it by 600 and then we get these values here as well. So that's kind of gives you this whole inventory of the light bulb. And this is, again, we are just talking about a small light bulb, and there are so much items right there already. And as I said earlier, these are just, we just took 3 parameters, and for those 3 parameters we are seeing almost, and for this light bulb, the incandescent bulb, very simple system, we are already seeing 3, 6, 9, and then you have 36 data points. So lots and lots of data points that need. That's why we need the softwares. The softwares are needed to get to understand this to kind of compile all the data. We can do a simple LCA exercise using Excel spreadsheet as well. But that's how it has started. Initial LCA studies were done using Excel spreadsheets, but now we have been using more and more software associated with that. So that's this is how the inventory is done, and we will start we'll recap this in a few minutes, like maybe a half a minute in the next video, and we'll start from here. So again, try to go through this example. If you want, you can rerun these videos multiple times. That's the beauty of having this online courses, that you can replay the video unless you get everything clear, because these are really very, very basic and clear stuff. If you understand this example, that's why I'm taking so much time on this example to explain you in a very nitty-gritty detail, so that if you understand it, it would be much easier when you look at any other exercise for LCA, whether when you use it for your research, for your teaching, or whatever purposes. Thank you, and I'll see you again in the next video.